with one more flipped classroom video. 3 tips before we start. You can always speed up or slow down this playback speed if that helps you get through the video. Second, you can pause the video at any time and catch up on your notes. Last, you can turn on the captions and watch my words go by on the bottom of your screen. Today's topic is inverse functions. But before we go into that, I'd like to talk a little bit about inverse operations because the idea of inverse in mathematics is important and consistent. So inverse operations are mathematical operations that undo each other. For example, multiplication and division are considered inverse operations of each other for the following reason. Check this out. 6 times 2 gives us 12. Now if we do divide by 2, we get back to 6. So basically what I'm doing is I'm multiplying by 2, then dividing by 2, and I'm back where I started from. So that's why multiplication and division are considered an inverse operation. In a more simple way, so are addition and subtraction. 1.2 plus 7 is 8.2. Now if I go right back and subtract 7, I'm back at 1.2. So in this way, multiplication and addition and subtraction are inverse operations. Now let's take a look at that idea applied to functions. It's really simple. Functions are inverse functions if one undoes what the other one did. So here we go. F of x and g of x are inverse functions if f of g of x equals x. And you saw in the last lesson, we had a last example that covered that. So basically what this would mean is that if I did g of x and then did f of x to that, I'm back at x. It's kind of like when I took my 6 and I multiplied it by 2, that could be my f of x, and then my g of x is divide by 2, and it takes me right back to 6. And the following is also true. If they're inverse functions, f of g of x is x, and g of f of x goes back to x. And you can test that with your algebra skills. All right, let's take a look at some notation. This is important. It's not a big deal, but you do need to understand and use it. So for f of x, if we wanted to denote or describe or identify the inverse function, we just use f to the minus 1 power. It's not read minus 1, it's read f inverse of x. And that's the inverse of f of x. Pretty straightforward. You're going to see this notation in your textbook. Thus, knowing what we do with an inverse function, f inverse of x is just x. So this is something we've been talking about. Now you're seeing it in this form with this special notation for the inverse function. All right, I bet you figured this was coming. You're going to be given a function and you're going to be asked to find the inverse function. Now the super simple ones probably can do it without much algebra. Like if the function is 2x, then the inverse is going to be 1/2 x. Because 2x just doubles it, 1/2 just cuts it in half. So it's pretty easy to see that those two functions would be inverses of each other. However, if you have a function like 2x plus 4, not so obvious. So there's a method. Always in mathematics, there's a method. So let's go over that. Okay? So for finding f inverse of x, what you do is you take f of x, the function, you reverse x and y, and remember, f of x is just a fancy way of saying y. So we reverse x and y, and then we solve for y, because y will no longer be alone on the left side. So you have to rearrange the equation to get the new y, which is the old x, alone, and that will give you your inverse function. So let's take a look at that. Here's our example. F of x is 2x plus 4. Let's find the inverse. So the first thing I'm going to do is just write y equals 2x plus 4. Remember, f of x is just fancy for y. So y equals 2x plus 4. Now what I'm going to do is reverse my x and y. So now I have x equals 2y plus 4. All I did is I switched my x and y, and now I'm solving for y. So first thing, subtract 4 from both sides. X minus 4 equals 2y. Now I'm going to divide through by 2, and I'm going to bring my y over to this side because that's our standard. So this divided by 2 gives me y. X divided by 2 is 1/2 x. And negative 4 divided by 2 is negative 2. So that is my f inverse of x. So now I can write that here. F inverse x equals 1/2 x minus 2. Okay, now once you've done this, there's a check. You want to check to see that f of f inverse of x equals x. So we're going to do f of f inverse of x equals x. So now let's do that. This is the trickiest algebra we're doing in this section. So f inverse of x is 1/2 x minus 2. And we're going to do f of that. So f of x is 2 times x plus 4. So we're going to put the 2 out here, and we're going to do plus 4. So here is f inverse of x, and now we've put f of x around it. So we're taking that result, we're doing f of x to it. Now we just have to simplify this down and prove that we end up with 4. So check this out. 2 times 1/2 is x. 2 times negative 2 is minus 4. This 4 just comes down, and guess what? We got our x. So this confirmed that we did the right thing when we found f inverse of x, because we just showed that f of f inverse of x does indeed equal x. I'm not going to lie, the algebra is going to get complex on some of these problems. So let's take a look at one of those. Here's my function. F of x equals x over x plus 5. Now the first step is to find the inverse function. So what we're going to do is we're going to switch our x and y. So this is our fancy y, so that's just y. So we're going to put our x there and our y's where our x's are in our function. Now this is a little bit more complicated. Now we need to isolate y on one side. So what I'm going to do is multiply both sides times by y plus 5. That'll get this off this side, and we'll just have a y. And I'm going to multiply this side times y plus 5. So I'm going to have xy plus 5x equals y. So that's that first step. I just multiplied by y plus 5 on both sides. Now I need to isolate the y. So what I'm going to do is get this y on this side and get the 5x over on that side. So I'm going to have xy minus y, I subtracted my y to get it over, equals negative 5x. I subtracted my positive 5x to get that over. Now I can factor this side. I've got a y in both terms, so I can factor the y out and get x minus 1 equals negative 5x. So I'm getting really close. Now I can just divide both through by x minus 1 and get y equals negative 5x over x minus 1. There is our inverse function. So not too bad, but you do have to know a bunch of your algebra tricks and be comfortable multiplying and dividing both sides of the equation by binomials. We've got some binomials here where we're doing that, and you've got to be able to keep track of your signs and all that good stuff. So this is pretty straightforward, although I would say maybe not easy, especially if your algebra skills aren't really honed. Okay, now if that's all they asked you to do, you're great. Check the back of the book, make sure your answer's good down the road. But here's where it gets fun. What if they say, show that f of f inverse of x equals x? Now this is your proof that what you did here was right. So if you're on a test, you can always prove it. This is a lot of steps, so you'd only do that if you had enough time to do that. Or, important point, if the problem said, show that, then you have to do your algebra and make this work. So this is pretty complicated. I'm going to break it down into like 3 different chunks, or I'm going to ask you to take it as far as you can. So that first chunk is the plug-in step. So see if you could write a plug-in step for f of f inverse of x. And then we're just going to manipulate that on down and try to resolve that back to x. So pause the video and do that plug-in step. Okay, here's my plug-in step. So what I did is I took my inverse function, there it is, and I put it in the original function wherever x appears. So this function is just one fraction, x over x plus 5. So instead of the x on the top, I have my inverse function, which is minus 5x over x minus 1. Then on the bottom of the fraction, again, my x appears right there. So I have my inverse function sitting right there, minus 5x over x minus 1. And then this 5 is just being added on, so there's the plus 5. Now, you have a fraction over a fraction. And this bottom part isn't even only a fraction, it's a fraction plus a number. So we've got some work to do here. So if you're feeling bold, I'd like you to see if you can take that another couple steps. Oh boy, here comes some more algebra. Okay, so what I did going from this first step, which is our plug-in step, is I just focused on the bottom. In fact, the next two steps, I've just been focusing on the bottom because this is the most complicated piece. This is a straightforward fraction, so I'm going to deal with that towards the very end. But I need to get this into a straightforward, just single fraction. So to do that, I need to convert this 5 into something over x minus 1. I need to get common denominators. So what I did is I just did 5 times x minus 1, okay, over x minus 1. This is the same as just 5. I can cancel the x minus 1s. I'm not because I need them right now. I need the x minus 1s on the bottom of both of these. So moving down, I kept my top the same. That's just this top there. And then on the bottom, I have this term is the same. And then I just rewrote the 5 as 5 times x minus 1 over x minus 1, which is just 5. So that's my next step. Now, my third step here, again, I left the top the same. I'm not going to do anything with that yet. I'm getting closer and closer to getting my bottom to be one simple fraction. So what I did, I have common denominators in this step. So now I can just combine what's happening on the top over one of these denominators. So what I did is I have my minus 5x there. I did my distributive property here, 5x, or 5 times x minus 1 is 5x minus 5. So I just did my expansion there, got that down. So now on the bottom I have minus 5x plus 5x minus 5 over x minus 1. And I think you can see where that's going to go. So what I want you to do is pause the video and see if you could take this a couple more steps. All right, let's see how you did. So again, I'm simplifying the bottom. So one more step where I leave the top alone and just manipulate the bottom. Here we have a plus 5x and a minus 5x. So those are going to cancel out. And so here's the top from before. Now here on the bottom, I just have minus 5 over that x minus 1 common denominator that we used before. So here's where you need to remember when you have a fraction divided by a fraction, you just flip the bottom and multiply. So what I did is I multiplied the top by the bottom, but by the bottom flipped. So here's my top, minus 5x over x minus 1. I flipped the bottom, so it's x minus 1 over minus 5. Now, pause the video and carry that through to the end and see if you wind up with just plain x. And we're here. Check it out. My x minus 1's canceled out. I got one on top, one on the bottom, so they go away. So that gives me minus 5x over minus 5. Now check it out. The minus 5's also cancel out, leaving me with x right there. So I did indeed show you that for my function, I got my inverse function correctly, and then I used my algebra skills, and boy, that was a bunch of steps. There's like 6 steps there to get the correct answer. All right, there's one last thing we need to talk about in terms of inverse functions. Graphically, there's an interesting thing about them. And if you have the function graphed, you don't even need to know the rule. You can make the graph of the inverse function just quick and easy by knowing one simple trick. So let's take a look at these two functions. If you'll remember, these are the two functions that we played with in the beginning of the video. My f of x is just 2x plus 4, and my f inverse of x was 1/2 x minus 2. Pause the video and graph those functions. All right, let's take a look at that. These are two easily graphed functions. They're both in gradient intercept or slope intercept form, so you should be familiar with that. Let me go over that really quickly. For f of x, our slope is 2 and our intercept is 4. So I started on the intercept of 0, 4, and I went up 2 over 1 for my slope, and then left 1 down 2 for the slope there, and I drew my line. So that's f of x. F inverse of x has a slope of 1/2 and a y-intercept of -2. So I went to my -2 on my y-axis, and I went up 1 over 2, up 1 over 2, got my points, and drew my line. Now, what I want you to do is take a look at that graph. There's something going on there that you can see from the graph. So pause the video, think about that. So let's see if you figured that out. There's a line on the graph, y equals x, and that's just a straight line where every y coordinate is the same as the x coordinate. So you have the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. So you'll notice I put that line on the graph, and it does some things. First off, it goes right through this intersection point where our f of x meets our f inverse of x. It's also, you can see from the graph that this line is a reflecting line for the function. So the function, if you reflect it across the y equals x line, the reflection is going to land right on the f inverse of x line. So if I were to just throw this function on the graph, you could sketch in the y equals x line, and then you could reflect across for each point. So the distance from here to here is the same as the distance from there to there. So we could do that. And basically, now here's the trick here. This is the point 5 or 0, 5. This is the point 5, 0. So when you reflect across y equals x, you just switch the x and y coordinates to get your new points. And then here, you can see that this is the point -4, -4. And that point, if you want to check, that point satisfies both equations. So if you put this x value in this equation or that equation, they will both spit out the y value of -4. So that gets you a whole lot of stuff here. In the exercises, you're going to have to find inverse functions. You're going to have to test them to see that f of f inverse of x does indeed equal x. And then you're also going to get some graphs, and you're going to need to sketch in the inverse function based on this idea where you have the function, you draw in the y equals x line, and then you use that to reflect across to get a graph of the inverse function. Now that you've watched the video, take a moment to jot down any questions so you can bring them to our next class. Remember that you can always watch the video again to deepen your understanding. If you enjoyed the video, please click like or subscribe.